the wind resource assessment and wind technologies. So this part is basically focusing on wind resource assessment. And by the terminology wind resource assessment, what do we mean is to evaluate the availability of wind at a particular location in such a way that whether those available winds can be converted into wind energy or not. So it's the process to determine the availability of wind and to assess whether that available wind is converted into wind energy or not. So let's begin. First of all, let us try to understand what are the main causes of flow of wind. So wind is the natural movement of air due to two effects. One is the difference in atmospheric pressure. And it is obvious that when there is a difference in the pressure, air moves from high pressure region to low pressure region. And the second phenomena is the uneven heating of Earth's surface. Because the Earth's surface is made up of different types of land and water, so it absorbs the sun's heat at different rates. When the Earth's surface is heated, the air becomes lighter and rises above, causing a low pressure area to form. Cool, dense air with high air pressure then flows underneath the warm, less dense air, forcing the warm air to rise. These two are the fundamental phenomena which causes the flow of wind. Also, the rotation of the Earth causes Coriolis effect, which is the directional skew of wind to the right in the northern hemisphere, to the left in the southern hemisphere. So this Coriolis effect also causes the flow of wind. And this Coriolis effect is basically the deflection of air because of Earth rotation. And because of Earth's rotation, you can see in this figure that in the northern hemisphere, air deflects to the right, but in the southern hemisphere, air veers to the left. Now, if you look the down figure in which red and green arrows are marked, you can see that objects moving from the equator towards the pole, that is indicated by the red arrows, move into a region of slower rotational speed, and their paths are deflected ahead of their point of origin. Similarly, the movement from high latitudes to low latitudes, shown by the green arrows, goes from the region of low speed to a region of high rotational speed. And there is a deflection behind their point of origin. So these three phenomena are important in order to understand the causes of flow of wind. And that is why, if you look in the upper figure, you will find that it causes three types of winds. One is the trade winds near the equator, then westerlies near the poles, and finally the polar easterlies. So these three regions are having different types of flow of wind. And wind resource assessment, or the availability of wind, or the determination of availability of wind, is particularly important because wind speed is the main factor that determines how much energy a wind turbine can generate at a particular location. Wind speeds are usually higher the further they are above the ground. And favorable locations for wind turbines include top of the hills, open plains, bodies of water, and the mountain gaps. In general, a minimum wind speed of 12 to 14 km per hour or 4 to 5 meters per second is required in order to generate electricity from a wind turbine. Strong winds of 40 to 60 km per hour, that is 12 to 14 meter per second, generate at full capacity, and winds of less than 90 km per hour, that is 25 meter per second, is considered to be the safe region. The optimal range of wind speed for wind power generation lies between 4 to 12 meter per second. Now, if we look at the wind regime in India, then we will find that the entire wind climatology in India is influenced by the strong monsoon circulation. Southwest monsoon during May to September brings the best winds. Wind speeds during November to March is low, except in southern tip of Tamil Nadu. And if we look in the entire geographical dimension of India, we will find that best windy sites we will find in Kerala, Karnataka, Tamil Nadu, Gujarat, Andhra Pradesh, and Maharashtra. The states like Madhya Pradesh, Rajasthan also have moderately high wind speeds, and therefore we can find several good wind sites. Now, the word I have used here, that is wind site. Basically, wind site is that particular geographical location which is considered to be a potential wind generating region. So wind resource assessment, as I have earlier indicated, is basically the process to determine the wind at a particular location and evaluate the available wind in order to assess their suitability to be converted into wind power generated electricity. The objective of a wind resource assessment is basically to gather important data on wind patterns, such as wind speed, wind direction, and the generated power density. Wind resource assessment is basically to determine the feasibility of wind energy projects and identify suitable sites for wind power projects. Wind resource assessment also help us develop the policies and regulations and provide support in order to consolidate the design, the construction, and operation of wind energy conversion systems. Wind resource assessment is basically carried out in 3 stages. The first stage is called prospecting, which is also called as preliminary area screening. The second stage is called validation. It is also called as area wind resource evaluation. And the third stage is called micrositing, known as micro survey. So as we can see here, that wind resource assessment requires us to start with the prospecting process, move to validation, and then move to micro survey. Prospecting is the process to screen a relatively large region or large area, like a state or a utility service territory, for its suitability towards wind power generation. Wind resource areas are based on information that is received from the nearby airport, or looking at the topography of that particular area, or looking at the flagging of the trees, or any other natural indicators. At this stage, that is as the stage of prospecting, the new wind measurement sites can be selected. So at the end of prospecting stage, before moving to the validation stage, we will identify the potential wind sites to carry out the wind resource assessment. Here, we must be very clear that objective of prospecting stage is not to identify a wind site, but rather to identify a wind site suitable to have the second stage of wind resource assessment. So validation is the stage where wind measurement programs to characterize the wind resources in that defined area is being considered. The most common objective of this validation process is to determine or verify whether sufficient wind resource exists within the area to justify further site-specific investigation. So validation is the process of initiating the measurement at that particular site. So prospecting was a qualitative determination under the wind resource assessment, whereas in the validation process, we make a quantitative assessment. Then comes the micrositing or the micro survey, because the smallest scale of wind resource assessment is micrositing, which has the main objective to quantify the small scale variability of the wind resource over the terrain of interest. So in the micrositing, basically what we do is to position one or more wind turbines on a parcel of land to maximize the overall energy output of the wind plant. So we will create a layout through a software in order to look that whatever quantified measurements we have made during the validation process, that how much that is translated into actual power generation when a layout of wind turbine through software is being developed. So we will start from the prospecting process. The prospecting process has 4 steps. We start with the preliminary area identification, go to field survey, then rank our sites, and finally we select the location for placement of monitoring towers. Once this prospecting is completed, we will move to validation. And validation is also carried out in 4 steps. The first is we will install the monitoring tower, that is called wind mast. After that, we will develop a monitoring plan. Then we will go for data analysis. And finally, we will ensure the quality assurance of the collected data. Once the validation process ends, we will go for micrositing. And in the micrositing, there are 3 steps to be followed. One step is to development of design layout of a wind farm, and then optimal allocation of the wind turbines. And after that, in the third, we will run that software in order to optimize the park layout so that maximum energy output we can get. So these are the 3 stages. In the prospecting, the first step is preliminary area identification, the objective of which is to determine or verify whether sufficient wind resource exists within that particular area in order to justify further site-specific investigation. It is very, very important that in the preliminary area identification, what we will be doing is we will be screening a large area. So for preliminary area identification, this site-specific investigation will be carried out first by large area screening, by wind resource map lookup, by the use of existing wind data taken from the nearby airport, and also to look at the topographical indicators, that is to look at the flagging of trees. This investigation also requires large area screening with a review of existing wind resource maps, data, and other meteorological information that is already available somehow. And also by review of analysis of the climatology of that region along with the topographical maps such as terrain form, land use, land cover, or other logistics like accessibility to that region or availability of grid infrastructure, etc. इसको